ECGs record the flow of electricity through the heart. Another way of thinking about this is that ECGs record the flow of depolarization through the heart. The graphic recording of cardiac electrical activity is made up of deflections, or waves. Positive deflections rise above the isoelectric line, whereas negative deflections, or negative waves, sink below the isoelectric line. The sensory instruments used to record the flow of electricity are known as leads. Just as one takes several radiographs at different angles to visualize a body part or lesion accurately, the different leads allow one to view the flow of electricity from different angles and thereby visualize the direction of flow more accurately. Each lead is made up of positive and negative electrodes. The leads record electricity flowing towards or away from the positive electrode. Before we plot the leads, a note on the orientation of the electrodes in the diagram. The red electrode is in reality attached to the left hind limb, but in the diagram it's represented on the caudal abdomen, as this will line up with the position of the limbs when the animal is in right lateral recumbency. There are three standard bipolar leads. The first one runs between the right forelimb and left forelimb, with the left forelimb electrode acting as the positive electrode. The second one runs between the right forelimb and the left hind limb, with the left hind limb electrode acting as the positive electrode. The third standard lead runs between the left forelimb and left hind limb, with the left hind limb electrode acting as the positive electrode. The three standard leads collectively form what is known as Einthoven's triangle. There are also three augmented leads, AVL, AVR, and AVF, that run from the center of the triangle to each limb electrode, with the limb electrodes acting as the positive electrodes. Now that these leads have been plotted, we can superimpose them onto what's known as the hex-axial lead system, allowing us to visualize the flow of electricity, or the flow of depolarization, on a 360-degree axis. If the flow is moving towards the positive electrode of the lead, it is recorded as a positive deflection. If the flow is moving away from the positive electrode of the lead, it is recorded as a negative deflection. The more parallel the flow is to a lead, the stronger the deflection. Conversely, if the flow of electricity is perpendicular to the lead, it will show up as a weaker biphasic or isoelectric deflection. That is, there will be two deflections, one positive and one negative. If they perfectly cancel one another out, the flow of electricity is exactly perpendicular to the lead. If the one deflection only partially cancels out the other, the flow is not perfectly perpendicular to the lead. Let's look at an example. In this case, the flow of electricity is moving in the direction of positive 90 degrees. This is perfectly parallel to lead AVF, and it's moving in the direction of lead AVF's positive electrode. Therefore, lead AVF will record a strong positive deflection. The flow is also moving in the direction of the positive electrodes of leads 2 and 3, although not perfectly parallel to either of them. Therefore, they will record moderate positive deflections. On the other hand, the flow of electricity is moving perfectly perpendicular to lead 1. So lead 1 will record biphasic deflections that perfectly cancel one another out, leading to a net deflection of 0. Lastly, the flow is moving away from the positive electrodes of leads AVL and AVR, and is fairly perpendicular to both. Therefore, these leads will record biphasic deflections that are more negative than positive. That is, the net deflection will be slightly negative. The flow is in the direction of negative 120 degrees. The flow is perfectly parallel to lead 2, but it's also directed away from lead 2's positive electrode. So lead 2 will record a strong negative deflection. The flow of electricity is also directed away from lead AVF's positive electrode, but it's not perfectly parallel to it. So this lead will record a moderate negative deflection. The flow is perfectly perpendicular to lead AVL, so this lead will record a perfectly isoelectric deflection. The flow is closely perpendicular to leads 1 and 3, and it's directed away from their positive electrodes. So these leads will record slightly negative biphasic deflections. Lastly, the flow is closely parallel to lead AVR and flowing in its direction. So lead AVR will record a moderate positive deflection.